we're going to talk about different things, but 3 things really to remember about what Toyota did and looked at in regards to its electric vehicle is in regards to using LEDs, and we'll talk about that. Why we're going to use LEDs, they don't use a lot of electricity. If you don't use a lot of electricity, what happens, you can use that electricity from the battery to get you a lot more mileage out of the vehicle itself. The other thing is aerodynamics. You'll see how the vehicle has changed in front. We did some things in front and rear of the vehicles for aerodynamic. Why? You make the vehicle a little bit more slippery, could cut the wind, less drag. Again, that's for mileage. And the other thing is weight. A lighter vehicle, like anything, carrying a 50-pound backpack on you as compared to not having one, it's a lot easier to move around, run, things like that. So that was the whole idea behind that. Some changes that we made in the vehicle as compared to the current generation RAV4 in the powertrain, of course, going from an internal combustion engine to an electric engine itself, and in the chassis, the brake system, shift-by-wire, tuning, electronic power steering, suspension, and the exterior, new colors, real new colors that are going to be available. New emblems that you'll see without. I'll show you some pictures of that. But we want to tell the world, not in a gaudy way that you're driving an electric vehicle, but in a real nice way. It's an electric vehicle that you're driving, a little bit different than the current RAV4. And heated power outside mirrors, front bumpers, grills. What you're going to look at are things that are made for aerodynamics, daytime running light, the rear spoiler, again, something that was made and put together for aerodynamics. Headlights, the use of LED, low beams itself, and other LED lights throughout the vehicle. I'll show you that. Like in the rear combination lamps. And other underbody changes to motor compartment, battery mountings, underbody aerodynamics. I'll show you some of that. And then interior, you're going to like that multimedia display, how it lights up the meters, the ornaments, the colors. It does some kind of neat things with color change. I think you'll like. So going on to the exterior itself. Here are the changes, as you can see, from the current RAV4, changing over to the RAV4 EV. So you look at the grille, a little bit different grille there, headlamp area, you can see a different headlamp type we're using itself. Daytime running lights, new placement, something new to that. Mirrors, I'll talk about what's new about those mirrors. You can see those door emblems placed in the front, or door emblems and emblems placed in the front of the vehicle. And in the back, pointing out that spoiler is a big thing. That's a big thing for aerodynamics itself. And the rear combination light, again, the emblems. A little bit closer look at that front end. As you can see, it's different. Why is it different? We want to cut the wind, make the vehicle more aerodynamic and slice through, make it easier to push. So that's the reason for that new grille itself. And then looking at those headlights, something new, but the addition of LED lights for your low beams itself. Why? Because they use less electricity. And then those daytime running lights, you see, that's where the current fog lamps are. Now we have daytime running lights there. LED, and what's neat about them, we'll talk about them more, but when you turn on the headlights, they do dim to as running lights. Yeah. Oh, and the neat thing too, if anybody asks, yes, you can shut off daytime running lights. I know, I like them, I use them, but some people don't like them. For the grille itself, something new for Toyota, this neat floating chrome accents on there, which is new to us. Gives it a real neat appearance, I think a little bit more classier look. Gives a little more highlights on there. Again, something different from the current RAV4. And then right there, the placement of the emblems themselves. As you can see where the badging is in the front, the sides, and the rear. Again, telling the world you are driving an electric vehicle. It is something different, but giving it Toyota's signature blue on there itself. It gives it a nice appearance. I don't know if you noticed, the EV looks like a plug. Yeah, it's pretty cool. I like that. Those little things in life. Colors. These are the colors that we're going to have. Super white, lizard pearl, classic silver metallic, and shoreline blue pearl. Super white is for fleet only. But when you see it, you really look good. The shoreline blue, I don't know, it's kind of my favorite, but they look good. They all look good on there, but really tastefully done.
With all the demos in various colors today, or are they all just
Are they the ones from yesterday? So
They're the 1A,
yes.
so yeah, we'll see all the colors at the warehouse.
Awesome. That's great, thank you.
Excuse me, my morning tea. Aerodynamics, and remember I said that was a big thing about this vehicle, aerodynamics itself. So what do we do to do that? Side mirrors, something different. We made them a little bit different. We borrowed from another vehicle, in fact from a Camry is where these things come from. But the idea is a mirror that's going to cut the wind. A lot of little small things that got involved in regards to aerodynamics itself. Rear spats, we extended those. If you look at that blue area right there, it's been extended out about 1.6 inches. You wouldn't think it's a big thing, but what it's now doing is even more directing wind around those tires themselves. And then the front, as you can see, when we go out to the vehicle, you see a little, almost like a little spoiler in front of the current spats, the ones that are on the RAV4. And what it does, again, directs air around the front wheels. So what do these all do? Basically, when you put all this together, it covers some of the reduction of drag itself. The mirrors itself, you reduce drag by 1.1%. And then those spats, 0.9, it's almost 1% there. The rear, that's the big thing. Basically what happens, you have this thing called a wake, and it's this disturbance. And believe it or not, aerodynamics in the rear is almost more important than in the front, because this wake causes this disturbance. If you guys are watching NASCAR, you kind of see this. That's kind of what every year NASCAR tries to figure out how much of this weight, because when those cars get close to each other, it's almost like a draw. It draws the vehicle behind you in. That's what weight does. It could do a lot of different things. So what we did in this circumstance, we took that spoiler and made it taller and longer. As we can see, extended the vertical and horizontal surface itself. And on the horizontal side, it's about 4.7 inches is that total mass is. So it's a big spoiler back there. Basically, it was designed to help with aerodynamics. And as you can see, this is what drag does. And just by changing that rear spoiler, you had a reduction of 2.5% in drag versus the production, current generation RAV4. Underneath, big area for aerodynamics, because you have holes and pockets, and when wind comes underneath the car, it could go anywhere underneath there itself, get caught up. What do we have? We now have drag. So what do we do? So right now you're looking at a gas current generation RAV4 itself. So we don't have an internal combustion engine, we don't have an exhaust pipe to deal with anymore. So what can we do? We now add these covers underneath there, underneath the motor, underneath the battery area, and then even behind the battery area called spats. So what we want to do is make that underneath the body slippery as possible. Again, kind of like race cars. I don't know if you've ever into Formula One, things like that. Those things are smooth underneath, but they use these kind of things to move air around to where they want. And that's what even that rear battery spat does. It takes the air from going, as it's coming underneath, going past the battery, and moves it along so it doesn't get stuck while there and causing drag. Also, what we do is when, besides, helping with aerodynamics, it does help underneath in regards to wiring, electrical systems. It does protect that. In fact, underneath that, if you took that and saw the top side of that covering for the battery, there's metal strips that are going down there. We saw a neat video the other day where they take this thing, it's like a bounce test and going over these, I want to call them whoop-de-doos, it's the motocross and thing. And it's slamming against there, and it's amazing, but the whole idea is we want to protect that battery. So.
Was that Mario? Sorry, was that on the previous slide? Each of those, so like 2.5% reduction, 1.7. But add them all up, and
I'm sorry, I should have said it. Yes, it adds up to 8.2% reduction in drag.
We're gonna be able to share this, right?
Yeah.
Share the presentation.
Oh, yes.
Okay, great.
And we'll email it to you.
Yeah, and those percentages seem small, but in aerodynamics, it
Oh, yeah.
And it's funny, they all start adding together. It's a little bit here, a little bit there, up the mirrors underneath. So in the aerodynamic sense itself, we're at 0.30. I mean, if you look at it, the current RAV is 0.350. But right now, if you look at it, we're now the lowest coefficient of drag of any SUV. In fact, we're now in the area of cars, sedans, which, as you know, SUVs, I mean, they're big, some are boxy, some are streamlined, but they're this mass that you're trying to push down the road. But because of the way the shape we made this vehicle, made it slippery, 0.30. That's pretty good, especially for an SUV. So, aerodynamics in conclusion itself. Lowest coefficient of drag of any current production SUV, we are proud of that. Coefficient of drag more typical of a sedan than an SUV. And optimize aerodynamics. Like I said, we changed the grille, the underbody, and that wake area for that. Lighting. One of my
All right,
Yes.
sorry, coming back to the aerodynamics. Thinking of things like the mirrors, the spats, the spoiler, will those be carried over to the conventional?
Don't know yet, haven't heard. As you know, Toyota, things change. We're always, the whole philosophy is, continuous improvement. I haven't heard yet, but I've been with Toyota around for a little bit. I've seen how things change. Things are, we've gotten things from Lexus, we've given things to Lexus. So I don't know, I haven't heard, but,
Things like those underbody treatments are tough to do on a gas car. You know,
Like the
you
spats
have
and-
to-
yeah,
Right,
so
so
you
you
got
allow-
it
Spats in the
exhaust.
spoiler you may see, but like the underbody pans and some of that
And
stuff.
that's why I didn't mention the underbody, just
Yeah,
the,
yeah.
I mean, the mirror,
Yeah, front bumper.
you know, if you look at it and say mirror, spat, spoiler, yeah, but we just chose not to make the current car more efficient.
Well, just keep in mind that vehicle also changes over to the next gen at the end of this year.
Yeah.
Oh,
The
good
gas
point.
is.
Yeah.
Doing a full redesign.
Yeah, full
yeah.
redesign, so.
Under
But it
NVH.
is cool, when they pulled those mirrors off the Korean spec camera.
Really?
Yeah.
yeah, because, you know, you think of SUVs, they have those big mirrors,
Yeah.
gears that stick
Yeah.
out, and, you know, these things are nice and small, and aerodynamic. It's kind of going around the world for, make a bit of
For
really
SUV
cool.
0.3, that's pretty good, you know, Camry's 0.27 or 2.8, depending on which model, you know, so we're pretty close to,
Yeah.
like you were saying, we're pretty close to our sedans, you know, getting down there. It's pretty slippery for an SUV.
So lighting, kind of like my favorite area because it's LED and the whole idea is to save electricity. Why? Because we do. Now we can use that to go a little bit farther. So for LED lighting stuff, headlights, the low beams themselves are LED, projector high beams, and unique styles. Got a really cool, clean style on there. So daytime running lights. I like these a lot. These look neat, gives it a neat appearance. You know, we're starting to see more and more of those daytime running lights, the LED style all over the place. It's really neat. 5 vertical LEDs, and like I said, they dim. You turn on the headlights. And then those, we have turn signals, those lights in there. Me, I love those a lot, especially in your vehicle. You know, if you're trying to go into the next lane, the person next to you know you're turning in. Oh, one more thing I forgot to say about the lights themselves. They have ratings. Who knew? But there's rating by a leading consumer publication, rates lamps themselves, 1 through 5. It's kind of funny, 5, if you want to say it's like the Olympics, nobody ever, you know, that 10, does anybody get it? But I guess now you do, it did yesterday. We got a 1 through 4, which is the highest ratings right now, so it's a really neat to be able to be given that. And also those lights themselves, the color of it is made to help improve, you know, the sight of the human eye itself. So again, more things done with those lighting to help out. Another neat part of the vehicle is the manual headlight leveling system itself. The whole idea is that you could adjust the aim level of the LED lights. So the thought is, if you put something heavy in a vehicle, and if you guys ever have a truck, put a lot of stuff in there, what happens to the lights that kind of, you know, shoot upwards and normally into the face of oncoming traffic? Oops. So the idea behind that is you could adjust that. And you'll see it when you get in the car. It's just left of the steering wheel itself. Looks like a little dial. You know, you see it 1 through 5. There is 11 settings that you could go in between, but you could adjust that and to be able to bring down those headlights itself so they're not going into the oncoming traffic.
So what's the reason for doing that manual versus an automatic, like in the Prius?
I don't know. I know for me, just personally, I like to be able to adjust it itself.
Yeah.
So I could do it. That's the whole idea too. Is we want you to keep it at 0 because 0 is natural, it's where it should be. But I think you could fine tune it maybe that way a little bit
It
more.
does give the driver some choice. Your automatic systems are gonna level it, but you don't have the ability to override it.
Yeah. And this one you could
But
make.
the other side of it, though, the automatic system's nice, and you don't have an inadvertent.
Yeah.
That's what
adjusted
I'm thinking
headlamps.
about.
Yeah.
That's what I'm thinking about.
Kind
Yeah,
of
there's
like
pluses and minuses to this.
Yeah.
that, you know, baby bear syndrome. Just right.
Mhm.
Rear lighting again with the use of the LED. Rear combination lamps, and the unique thing about them is the design, the color, unique clear smoke outer lens. The clear suggests advanced technology, and the light adds it, gives it that premium look on there itself. For the high mounted stop lamp itself, Chimsel, always a great word on there, but basically we have LEDs in there, clear lens with the 6 red LEDs, and the rear reflector itself, basically in there. And just in case anybody wonders what Chimsel means, caution high mount stop lamp. Those automotive words. Okay, so for LEDs, the reason behind it, basically we're looking at areas that are high usage, high wattage. We want to use LEDs there, again, to conserve electricity. What we did look at though is how much savings is that. 58 reduction of electricity usage, like 52 watts compared to the RAV4 itself, the RAV4 V6. That comes out to 132 pounds. It equates to that because remember, when you're creating electricity, you've got to be able to move something like turn an engine. It puts a drag on the engine when you do that. So that's what it's like losing 132 pounds for the vehicle itself, which gives us a 1% increase in range. I know it doesn't seem like a lot. I love it. Yesterday I the best analogy I heard from our engineers is we sell our grandmothers for 1%, and then they said, just kidding. But it's like, that's how important your, range is on this vehicle, so all that.
Sounds like you in the pit.
So, a recap of the location of those LEDs and the daytime running lights, the low beams themselves, stop lamps, parking lamps, side marker lights, tail lamps, and those high mount stop lamp itself. Some neat other features about the vehicle. Hey, zero emissions vehicle. There's no internal combustion engine in here, so it doesn't pollute. Really nice. Electronic transaxle system, which is a single gear ratio, and the electronic shift lever. I know you folks are used to Prius vehicles, same kind of thing. Uses shift-by-wire technology. Also activates appropriate shift control points based on information from switches, ECUs, things like that. Suspension itself, McPherson strut up front and double wishbone in the back. Gives it a really good feeling. In fact, driving this vehicle, when Dave and I were out in Arizona driving the vehicle, it felt a lot like a sports car. And I'll get into a little bit of reason that, but that battery has a big play on why this thing handles really well. In fact, one of the journalists I was with the other day, I thought he was going to start, drifting the vehicle when we hit a corner. So I was just like, whoa, hold on. But the thing was nice. I was like, that I hadn't tried before. I haven't tried drifting one of these. That's a new one. Star safety system with the vehicle, just like all our other Toyota vehicles. Analog brake system, electronic brake force distribution, brake assist, traction control, vehicle stability control, and smart stop technology, and hill start assist control. I don't know if any of you have ever driven a vehicle in places like San Francisco, trying to go up Lombard Street or those big streets with those big hills. That helps a lot, so you don't have to worry about rolling back and hitting the car behind you. I don't know if you ever tried a manual transmission up there. It's tough. Steering, rack and pinion steering assembly, and manual tilt and telescoping mechanism. When you get in the car, probably one of the questions I had a couple of times was, where is the adjustment so I can adjust the steering wheel? Right on the steering wheel, left hand, just put it right there. It's almost on the edge. You'll feel a lever there, pull it down, and tilt up, telescope, and stuff like that. Get you nice and comfy inside. For the interior, so we're looking at the interior itself, some of the changes. That audio system, premium Intel Touch navigation with Entune and EV application. The meter cluster, when you get in, you'll see that neat meter cluster itself. It gives you a lot of good information. The actual cluster, the premium Intel Touch system, I'll get into what's behind there. HVAC panel, it's totally new. It's neat. It's kind of even, when you go through the degree settings, it kind of scrolls, kind of like an iPhone. It's kind of neat, look, when you start, setting the temperature itself. The lower bezel area, as you know, where the shifter is, just like on the Prius vehicles. And the little button there, the last one down below, that's for the parking button itself. Always remember to set the parking button. I remember when I first started driving Prius vehicles, I forgot, you gotta press the button to put in park. For the interior itself, neat system how it's set up. Buttonless, so you won't see any buttons on there. Touchscreen, which gives it a real clean, simple, high-tech look to it. The neat thing about this system is once you learn it, and Dave and I will be out there showing you some things about the audio system itself, some of the buttons, what does what. Once you learn it, it's almost like intuitive. It's not like one of those, and I've been in cars, you seem like you almost have to use an owner's manual just to figure out how to set the audio system, even pick a radio station. Once you get used to it, you play with it, you're like, this is it, this is easy. And of course you have your controls on your steering wheel itself for volume and preset station. Closer look of the instrument cluster itself. Basically sitting in the car, this is what you're going to look at it, the portion on the top. Your power meter itself, telling you how you're driving, your range in there, your speedometer, your placement of your transmission itself. And the multi-information display is the one on the right. When we're in the cars, Dave and I have some more information about that, but we'll also show you what that is when we get in the cars. And that neat glow ring in there, and that color gives you, give you some other info about that color, that blue color. Some changes when it changes to red. Multi-information display, this is what you'll see behind there. These are some of the items themselves. Really neat stuff. Driving range, navigation, which is coming soon, efficiency, eco-coach, CO2 reduction, and then to the bottom left, that is for your HVAC system itself. And as you can see, the 73 numbers, they scroll, like I said, kind of like an iPhone, really. And to the right is your actual on the information display itself, where your radio is, if you want to call it your AV unit itself. But we'll go into things with behind some of those buttons. So what happens when you start up a car? Your vehicle does a system check. It checks the vehicle. How's it doing? Okay. And then when you shut off the car, you'll get this trip summary. So it'll give you an idea of how your drive was, efficiency, or your eco coach, your distance. So going behind there, excuse me, I'm going to use my notes so I'll give you the right information about that, but a little bit about information about the multi-information display itself. When it comes to driving range, displays an estimated driving range according to the amount of charge remaining in the traction battery and air conditioning setting. And what's neat about that is when you go into, using your air conditioning or heating system, we'll show you there's a little button, an eco button. And as that changes, that little orange bar is going to go up and down. It's telling you about your electricity that you have, your battery, what's available on the battery itself. So we'll show you that. It's a pretty neat system, how it works. Trip efficiency displays the average power consumption in intervals of 5 minutes. Current power consumption is simultaneously displayed, allowing it to be compared with previous power consumption rates. And then efficiency, just letting you know how you're driving at that time and what's going on battery-wise, electricity-wise. Eco Coach, and it's an indicator that provides feedback to the driver, rating their acceleration, speed, and braking. This does not work in cruise control. The reason is it looks at your pedal, your accelerator pedal, how you push that. You're not pressing the accelerator while you're in cruise control, so you're not going to show anything. And it does operate at speeds above 20 miles per hour. CO2 reduction is really neat. It's showing you how the vehicle is doing as compared to if you're driving an internal combustion engine. And as your savings increase, the tree grows. And then your accelerator power, basically, it's going to show you how much electricity you're using at that time. What's neat is when you're in that section, if you turn on things like the headlights or a seat heater things, you'll see that bar drop a little bit. It's not a lot, but you'll see that drop and you'll see it increase as if you're turning these items off. So if you want to see how much electricity you're actually using at any moment or any time, that's the best way to check that out. You guys are familiar with this, the shifter itself, and it's located right down here, so it's not up here on top like on the Prius. It's down, down between the seats themselves. And again, that parking button. Always put in park. Dual zone climate control. It's a neat system as you're looking at the head unit there on the left. Different things. We do have an eco switch available for the vehicle. We do have something called eco low, which is recommended, and eco high. Seat heaters automatically come on in eco modes themselves. An HVAC panel has capacitive touch sensor controls, which are really neat. You just slightly touch them, and they will change. The climate control system itself, it's a really neat system. As you know, when you turn on the climate control, you're now using electricity. You're using a heck of a lot of electricity itself. So what we've done is we've said, okay, the recommended is to do eco low while you're driving the vehicle, while you have to save and conserve electricity and to be able to get the mileage you want out of the vehicle. So there is a normal. Normal is basically what we're used to in our vehicles right now. The air that's coming out, the speed of the blower itself, the working of the heating unit system, and the AC compressor. So when you go into eco low, what it does is reduce the blower speed. It reduces the heating element, how it's working itself, the efficient, and not one is efficiency of it, but how it's heating, or if you have the air conditioning system on, it controls the operation of the actual compressor itself. And you'll notice that when you're in the vehicle and hit eco low, eco high, you'll hear it slow down, the blower will slow down. Again, if you go into eco high itself, you'll get more reduction of the blower, more reduction of the heating unit, and of the cooling system itself. So you're thinking, wow, I go into any of those, I'm not going to feel that full heat that I want, or I'm not going to be as warm. Seat heaters kick on when you do that. So that's nice. I know you might be thinking, wow, seat heaters kick on, that uses a lot of electricity. Believe it or not, the seat heaters use less electricity than that heating element or the air conditioning element. We're talking about seat heater uses wattage as compared to the cooling air conditioning heating system is kilowatts. So there's a lot of difference. Seat heater uses 4.3 kilowatts. The heater uses 4.3 kilowatts, the seat heater uses 86 watts. So now we're talking watts versus kilowatts, so that's the big difference there. That's why we do that itself. So that's why eco low is the recommended to get the mileage you really want on the vehicle. So looking on top, like I said, using air conditioning, heating system itself, your driving range, as you can see, from normal to eco-low to eco-high, driving range will change. Using eco-high, you will get the most mileage on the vehicle itself. And power consumption, that's versus the heating unit versus the air conditioning system. Internal combustion systems itself, the byproduct of that is heat. Free heat, because it's just coming, you've opened a hood on an engine, it's hot, it's easy. So what did we do? We put in a radiator, we put in a heating unit, radiator heating unit, blow air through there, air goes through. This is a simple way. It goes through the system, goes in a cabin, it warms you up. That's pretty much free. Of course, if you turn on the heating system itself, the blower. But if you just open the vent, like anybody driven old cars, basically it just goes in and it'll heat the car itself. On this one, it's different because now you have to generate that heat. You have to use electricity to heat the air. So what we're looking at here is for winter months, it takes more electricity to cool the car, to heat the car itself. So that's the kind of difference on there. So that's why we're saying in the winter, eco-low, seat heaters on.
Do you capture any of the heat from the motor? The main drive motor?
There is a radiator. We use a radiator and that cools it off. But we don't blow any heat. Yeah, it's used from an electrical grid, and we're using electricity to heat it itself.
Can you preheat, pre-cool while you're on charger?
I'm gonna get to that. Okay. That's one of the other neat things about this vehicle itself. Pre-climate system. Good, you're just right there. Excuse me. So yes, you can choose to pre-cool or preheat the vehicle. The neat thing about that is because if you do that, more than likely you're going to be plugged into the grid, and when you're doing that, you're preheating, you're using electricity, right? But you're putting electricity into the car. That's the nice thing of doing this before you take off. And I'll get into a little bit more of how that works. And then the nice thing about this, there's a timer you could set up. You set it through your navigation screen or through your smartphone itself. So the premium Intel Touch navigation with Intune and EV application. Oh, that dash, it's really neat. Left side is normal mode, nice, cool, mellow blue. Left side, or the right side, I should say, left side normal, right side, sport, fiery red. So when you're in the car, press that sport button, you'll see it, and then the changing of the light. But it is there to let you know if you are in sport mode itself, you're out of normal mode. And like I said, I call it that fiery red, so. Into the head unit itself, the ADN head unit. So to give you a little idea of what those buttons do. The big one of the questions that was asked to me the last couple of days is how do I shut this audio system off? It's the button right there itself. Just go ahead and press that, that'll shut off. Also, as you know, on the steering wheel, holding the mode button down, that mutes it out. Plus, that little audio control, when you press that little button, you have a drop down, and with the drop down, you could adjust the volume, or you could change station, doing a quick scan or scan one by one. But also, there's a mute button on there as well. You got 3 ways if you want to shut off the audio system. And that little gear on the bottom right, you go in there, that'll take you to your information screen itself. You want to set destinations, things like that, through your nav system. Oh, bottom button right there in the middle, home button. From any screen, press that button, it'll take you home. This is home, main menu. So, if you want to press a button there, go into map, what's behind there? That'll just take you straight to your map itself. Go in, behind there, EV button, and go into your range map itself. Okay, this is a neat little thing. Remember I told you when you start turning on things like your air conditioning and heating itself, you start using electricity. Okay? So if you want to know is how far can I get with the vehicle, either one way or round trip, this range button itself. So if you pick one way or round trip, the circle will either increase or decrease. So of course if you're going one way, your circle is going to increase because you're just going there and not going to come back. But if you want to go there and back, or if you want to make it home, it's going to decrease to give you that ability to show how far out you could go and come back. Why is there a circle within a circle? Because now something is turned on, like the heating or air conditioning system itself. And when you're in the car, try that. Go to the screen. And what you're looking at is the outer ring is your maximum distance itself, and the inner ring is how far you can go with what you have going on with your air conditioner heating. So say if I turned off my air conditioner heating itself, that inner circle would go away and you would just see the outer circle itself. Because you're not using electricity, I have now a longer range with the vehicle. So it's neat. The vehicle tells you this information, tell you how far you can go with the vehicle itself and how far you can go with you turning on these things. And it's neat, as you shut things off, like the air conditioning system, putting in an eco low, eco high, eco or normal, that inner circle will change. Or if you just shut off the air conditioning, the inner circle goes away, air conditioner heater.
Sorry.
Does that system take any other information into account other than the internal settings in the vehicle?
I've played with things like when you turn on the headlights, turn on the radio, because now we're only using wattage. No, you will not see that change. Basically, the change will be, it's because the heating and air conditioning draws so much electricity, you'll
Sure.
see that. Which I said, going into that aux screen in the multi-information system, that's where you'll see that. You'll see the changes as you turn on your headlights.
I was thinking more of like external or environmental conditions.
Yeah.
Did you hear anything?
Now, it will take into consideration what the vehicle's range estimation is for your driving capabilities based on your recent driving habits, though.
So it does kind of keep an
Yeah, so when you-
average.
Yeah, so what's gonna happen when you get in that RAV EV and you turn it on, today, you're gonna see a range estimate based on battery state of charge, if she's fully charged or not, and also what the last 15 or minutes or so of driving was done on that vehicle by whoever drove it before you guys will drive it today, and it's gonna have a best guess. That'll be your outer ring out there.
Okay.
I was talking about. So it will adjust that based on what it thinks is going on, and then that will adjust as you start to drive. It'll start to take in your driving mannerisms and then adjust your range estimate accordingly.
Will it give you a more accurate estimate if you have a route programmed in, if you're traveling by interstate and versus traveling through the city and?
Nope, in fact, it won't predict it based on that, it will just basically predict your range based on battery state of charge and what your power consumption has been of late, and it will not factor in at all what you're planning to drive. It's gonna wait and see what you do, and then it's gonna adjust. It's got an algorithm in it that it does, uses to calculate what it thinks you can do based on the traffic.
Out of
And then,
curiosity.
if you're driving like 100 miles an hour versus, 20 miles an hour.
It's
you're
gonna
using-
react to that.
Yeah, you're using a lot of electricity doing that. And believe it or not, the car can do 100 miles an hour.
Can you explain the little caution button down here in the lower right corner of the car in the exclamation mark in the house?
You're away
I
from
never
Just
saw
don't
that.
run into
I never
houses.
either. I was looking for that and I haven't.
too far away from
So-
town.
Because I just
So-
don't get out
Spell
and see
that.
that, and go, dang, I should
cut
pay
Tucci
attention.
on.
The only
Well, it's
thing,
just saying, you can't get home.
I
Well,
got,
then it's misspelled, so maybe this is just a prototype.
The nav does have some traffic capabilities for
Yeah.
access.
There's no
and-
place.
that's what I'm thinking it was because it does have the access, the ability that,
You'll also get
tells
a-
you things.
Maybe when you get really
It'll
low.
give you a weather broadcast alert up here too, if it's activated in the car. But if you can touch that, you'll see a weather alert. You can see that the other day.
Dave, just one follow-up on the range prediction. I mean, is there any plans that you guys are looking at to take terrain data into that range?
No.
No, it's really tough to do it. I mean, obviously there's map databases out there with topo maps and whatnot, but it still doesn't factor in how you, the driver, are gonna operate the vehicle. So what it's
Right.
gonna do is constantly look at, it's just gonna constantly read your throttle inputs and how much reach and braking you're doing, and it's gonna calculate that mathematically. And that's actually more accurate than trying to factor in terrain and whatnot, where, I mean, if all of us took a RAV EV out and drove a certain drive cycle, we're gonna all get different fuel economies or
Sure.
electricity economies. So it's better to just try to read the vehicle's actions, and it's pretty accurate. They've done a pretty good job, I think.
They did, because it did look at, because I was with multiple different drivers, and we were going over hilly areas and things like that, and some of them just floored it going up a hill, and you could, there's
That's what
gotta
I was
take
sort
all
of
that
wondering
into
is like, in a flat terrain, I'm sure that's really
But what you will
predictable,
see,
but as soon as you start going up and down, I would think it
But
really,
it's gonna adjust.
It will
It's gonna
adjust.
It will
as you
adjust.
go
in fact, the other day.
based on your driving, not on the terrain.
I think my question is up for trip planning, so I wanna drive from here to grandma's house, and grandma's house has 50 miles of interstate and 25 miles of 35-mile-an-hour road and 10 miles of 50-mile-an-hour road, and I wanna know if I'm gonna make it to grandma's house before I get halfway there and the car's turning. I trip that in, if I realize 10 miles away that I'm not gonna make it to grandma's house, I'm gonna need to charge somewhere.
We're not
And-
there yet.
Yeah, and so I think
Okay.
that's where
Yeah.
my thought process goes, because trip planning becomes critical when you've got a limited.
But I
Yeah,
think with this-
It's gonna be, I'm sorry, Paige.
Go ahead.
No, it's pretty tough to, once again, it's still difficult to predict that, because even if we know what roads you're gonna drive on, we don't know how you're gonna drive. We still don't know how you, the driver, are gonna behave. The one thing you will notice, that I noticed with journalists the other day too, is that our remaining range on our driving range estimate, based on our hilly terrain or non-hilly terrain, when we were going down some long downgrades, we would proceed for a mile or so and not see any range reduction, and in some cases, a range increase as The computer in the vehicle then started to factor in, okay, right now, we're coasting, we're regenerating electricity. Battery state of charge may not be going down at all, or maybe actually increasing. And also we're at a very light throttle setting because the driver's off the gas completely, right? And so it will adjust for that, but we're not there to where we can really factor in the road conditions.
But that's
I
almost a
think
false
it's-
positive, isn't it?
What's that?
I mean, that's almost like having a
Mhm.
false positive, isn't it? If it increases, but it's just based on the fact that at that moment it's not using any.
It is
You
true.
know, you're not really increasing your range.
But
Yeah,
you can't
you're
be-
actually recharging your
But
battery,
you
yeah.
can be increasing, just like a Prius plug-in or even a Prius or any of the hybrid family. That's the advantage that these cars do have over a gasoline car, is that you have the ability to turn that motor into a generator where your internal combustion cars can't get anything back when you're coasting down a hill. All you can do is go to a really lean fuel mixture, but you're still burning fuel, right? But there's no way to regain any of this electricity because they don't have the capacity to use that. But in this case here, yeah, you not only go to a zero throttle position on a long downhill coast, but your regen braking and coasting is gonna put electricity back in your battery. But, so your computer will factor that in, but to your point though, you get back down on the flat and you start hammering it again, you're gonna see that range adjust drastically. As the computer then now factors in what you're currently doing, so, I'm sorry.
You guys are gonna have a good opportunity, the big hill,
You
Palos
guys want to
Verdes,
cut Palos Verdes?
head up there,
Oh, cool,
see how it
okay.
handles the hill, see how it handles the
See
region.
what she does going up and down, because you'll see your range go down drastically climbing, right?
Right.
Heavy throttle settings, using a lot of power, and then when you get up, turn around, you're gonna see. I mean, my Prius that I drive regularly overcharges itself and has to turn the gas engine on to bleed off excess power when I'm going down some of the local mountains here in the area. And this car has such a big battery, you won't have that, but nonetheless, you have the ability where gasoline cars can't to actually extend your range when you're coasting.
And one important thing to note that they told us at Longlead was that the algorithm that they created to predict the range is very conservative. So more times than not, when you're in the vehicle and as you're driving the vehicle, you'll notice that, okay, we actually went 18 miles, but I only used 16 miles of my range. So it tends to err on the side of conservative because of all those unknown factors, not only terrain, but ambient temperature. So a lot of things, factors that we can't really correct for, so the calculation and the algorithm used is on the conservative side. So we had journalists actually say, oh my gosh, I have a Leaf, and when I step on the gas, it goes down 10 miles in my range immediately. And that just doesn't happen in this car. It's a much more stable prediction, and you'll see that when you drive it.
Does that prediction change over time as the batteries age?
Yes,
Sure.
as the driver, and it gathers data, it does, it changes based
Your
on.
battery over time is gonna degrade a little bit, your maximum state of charge is gonna be reduced, and it will factor that in, yes. It really does.
Sorry for that.
No, that's not. Ask questions. That's a fun part.
Well, okay, then you asked for it.
Oh.
No, I just one more. We're talking about extending range, going down hills, and can we go into a glide, a total freewheel?
Is the regen on the accelerator?
There's regen on the accelerator and on the brake pedal.
Oh,
On
both.
both, yeah.
So when you lift, you're gonna get some regen, which you actually do in our current cars to a point. But the Tesla system, remember Mara, the
That's
Tesla
so-
system.
Cooperative
Tesla's all on
region
the
is what they
accelerator.
call it, yeah, it's
So when
both.
you lift on this car, you get regen.
You get like a minimal regen like on the
Try it, guys.
Prius?
You're gonna have 5 hours to
Right.
try it.
Yeah.
Yeah,
There's
and-
also a B setting you can use too to increase that.
But I just wonder, max
B
kilowatt regen
Yeah, you
that you
have
get off the
brake.
accelerator itself.
You have a
But
B
you can
setting, like
use
you
What
do
does
on
it,
a
how,
hybrid.
what does it use to brake? There's no
Yeah,
ice.
it's just
to-
using more
It just
regen.
increases
Just more
your
regen.
It just
Oh,
changes
I see,
the
okay.
mapping on that.
Yeah, when you
Okay,
take your
that
foot
makes
off the
sense.
accelerator and it's in B mode, it'll,
Unlike Priuses, you can put this car in B and drive it around, it doesn't hurt your efficiency. This is all about just regen, there's no gas engine to have an effect. When
Right.
you put a Prius or a Toyota hybrid in B mode, you're telling the system to use the gasoline engine and the electric motor both to help slow you down, right? This is a little different, we're just gonna give you more regen.
So to Tony's question,
But
can you
can I
put it in
freewheel?
neutral and freewheel?
Do I have to
With
put it
no
in
regen.
neutral to freewheel?
Yes.
probably.
Okay.
Yeah, otherwise you're turning the electric motor, and anytime that's turning, you're producing electricity.
Okay.
If it's being turned by the car, I should say.
Okay.
Yeah, so if you're using momentum here to turn your electric motor, if the vehicle's moving and you're not in neutral, then yes.
See, and I'm used to my second gen, where I go to that no arrow state, glide, total freewheel, something that was
So
eliminated.
slight accelerator
pretty much.
pressure to
Oh, it's
to
just
kick out the region
Right.
without actually going into.
You'll find that point on this car
Possible
too.
there, okay.
You'll
Really?
find that point, yes.
Okay,
Okay.
cause I
That's
was.
what you're saying. You're gonna try to go for a net zero?
Yes.
You're gonna.
Yeah,
Yes.
yeah,
You can do that.
I do have the Prius plug.
yeah,
Yes, you
yeah,
can
that
do
net zero,
Tough to
that's,
do though.
I haven't tried that on this, try it today and see if you can find that point using your
Tough to the
instrumentation.
second gen's easy.
But yes, you should be able to do that.
Okay.
okay. Yeah, it's second
Yeah,
gen,
so
it's
you guys have
awesome.
a lot of fun out there.
Yeah.
Charge summary itself, we should, I did this.